Heat recovery systems can be tricky to design and operate, but for the last decade plus, HGA has had success innovating heat recovery systems for our clients. My name is Chad Helland, and I'm going to talk to you about HGA's latest innovation, full heat recovery engagement, or what we call FREE. The central utility plant exists to serve the heating and cooling loads. Some key performance metrics for a plant are energy use, carbon emissions, and utility costs. Let's look at a few heating equipment upgrades that achieve some combination of the reduction of these metrics. The first and most common option is to install high-efficiency condensing boilers. These boilers do reduce our three metrics when compared to a traditional non-condensing boiler, but are not the most efficient option. The next boiler option is electric, which has become very popular for clients who want to decarbonize. This does increase efficiency, but typically the utility costs increase too. While on-site emissions are zero, there are Scope 2 or grid emissions, which vary throughout the country. Utility companies are working to reduce their carbon footprint, but at this time, an electric boiler usually has higher total emissions compared to a condensing boiler. For the rest of the video, high-efficiency condensing boilers will be the baseline in the graphs. A good supplement to boilers are heat recovery chillers, which have efficiencies far greater than an electric boiler. These work by cooling down the chilled water loop and transferring the heat to the hot water loop for building heating. The dual purpose of the chiller allows it to achieve the high efficiencies required to reduce carbon emissions, utility costs, and energy use. A heat recovery chiller should be thought of as a heating device and be able to reduce the load on the boilers. The central utility plant distributes hot water to the hot water coils and chilled water to the chilled water coils. These are typically found in the air handlers, which condition the air supplied to the space. In the winter, outside air is used to cool down warm return air in a process called airside economizing, or free cooling. This makes a lot of sense and is a standard in the industry. Free cooling is great, but free is even better. So how does it work? First, the amount of outside air is reduced and the return air remains warm. The heat from the return air can be captured in the existing cooling coil located in the air handler, cooling down the warm return air before sending it back to the space. There are other coils that can be used in the building to capture waste heat, such as exhaust air streams. All of these coils tie into the same chilled water loop, which has captured heat from the air streams, and as a result, the water is warmer. Now we can follow the warmer water as it returns to the central plant. Using the heat recovery chillers in the plant, the heat is removed from the chilled water loop through the vapor compression cycle and transferred to the hot water loop. This reduces the load on the boilers and saves even more utility costs, carbon emissions, and energy. If a facility already has a chilled water and hot water system, it has heat recovery capabilities, and FREE could free up your boilers and maximize your central plant to reduce carbon emissions, utility costs, and energy use. If you have questions about how FREE could apply to your facility, please contact me or reach out to our energy and infrastructure team.